Okay, welcome to the first class of machine learning. So this slide may actually seem very familiar to you guys, especially the ones who have actually done the AI lab under me. So
Yes, sir.
can you see the screen? Can everyone see the screen? And can everyone hear me
Yes, sir.
loudly?
Yes, sir. We can see this thing.
Now, I shall actually cover this slide in this class. It is sort of like a recap class. Now, logistic integration is actually very, very important to understand the concepts of deep learning because deep learning actually is somewhat an extension of logistic integration. Okay, so if we can actually understand the algorithm behind this particular topic, deep learning will be face, especially seeing that how complex the architectures are. Here actually we shall also see gradient descent based optimization, which is actually the fundamental concept behind backward integration of deep learning. So I think this lecture is actually mostly you guys focused on the pseudocode because you have to implement the code. But in theory, we should actually focus on the theoretical aspects more because the questions in exam will come based on theoretical aspects of this algorithm. One moment, sound is coming from outside. I shall just turn off the window. So let us start from the basics. First of all, let us actually assume a very simple scenario where we actually all understand what is feature, what is output. These things I think we all understand. So I shall not go through them in this class. So suppose I have a data set where one sample X has two features, X1 and X2, and we have to classify this sample into one of the two classes, class 0 or class 1. Class 0 may be cat, class 1 may be dog. So this X, we can suppose that this X is an image, and this image has only 2 pixels. Seeing these pixels, we have to somehow determine if X is an image of a cat or it is an image of a dog. So as a humans, we can actually do these things fairly simply. We can very easily detect from an image whether it is cat or whether it is dog. But in computational process, this thing is not that simple because computer doesn't understand the high level value of features. It only understands the math. So does everyone understand this scenario? What I'm talking about here?
Yes, sir.
And I would request you guys to ask questions whenever you have any confusion. You don't need to wait for me to stop the lecture. You can just interrupt in between and ask a question whenever you are confused about something. I think that way we shall be able to learn better. So this is an example of binary classification because there are two classes, one is cat and one is dog. And a very, very simplified example because an image will never have 2 pixels, right? Currently we have cameras which are megapixel range. What does mega mean? Mega means 10 to the power 6.
6.
That means we have actually tons of pixels. So this is this is actually an oversimplified example, right? Now, in learning-based algorithm, what we actually do is we actually learn some thetas. So what are these thetas actually? These thetas are parameters. Now, we shall cover the learning aspect of these thetas a little bit later. Let us first understand what these things actually resemble to. Suppose we are dot producting x1, x2, these two features, and 1 with theta 3, theta 1, and theta 2. So I am still not actually telling where I am getting these values from. I shall discuss this a little bit later. Suppose I already have these three values. Someone I think messaged me something. Oh, no. Sabrina, I will actually request you to put the Facebook link in the message section here, so that new students can actually enter the group as well.
Okay, sir.
Okay. So when I dot product this particular vector, yes, please.
Sir, I cannot understand the 2 pixels that you described the first line.
2 pixels.
You have said that this sample was is about 2 pixels, where
2 pixels.
one is 0, another is 1.
No, it is. These are not actually pixels. These are class values, right? These are class values. These are not pixels. These are features, and these are class values. These two. Are we clear on this?
Sir, I do not clear about these features. Can you elaborate?
Yes, sure. Suppose you have an image in a mobile phone. Now, how many pixels are there in that image? How many pixels? Megapixel range mobile phones actually contain a lot of pixels, 10 to the power 6, 10 to the power 7, such kind of pixels they contain those images. Now, that image can be either of a cat or a dog, right? Now, those 10 to the power 6 pixels are the features of your image of the mobile phone. Now, 10 to the power 6 is a very large number to consider. So I am just assuming that your image does not have so many pixels. Your image only has 2 pixels, that is x1 and x2. Okay? And looking at x1, x2, I am trying to classify that image into either a cat or a dog. Now it is clear? Now is it clear?
Okay, sir. In that case, if it is a 2D image, then it would be a x1, y1, x2, y2.
No, not precisely actually. Let us actually see a more clear view here. Suppose this is an image. How many pixels are there here in this particular image?
4.
4
pixels. Okay. And if I divide these things more and more, then the resolution will get better and better, right? This is a more high resolution image. Is it?
Yes, sir.
This is obviously a more high resolution image. Okay. So considering so many pixels is very difficult for me when I am actually demonstrating an example. So I am only assuming that this image is very, very low resolution and it has only 2 pixels. Now is it clear?
Okay, sir. Thank you, sir.
And okay. Yes, welcome. Let me just clear this. Okay. Now I was talking about the thetas. So I still have not told you where these thetas actually come from. And I shall actually discuss that later on. First, we assume that we are actually dot producting this particular vector with this particular vector. These two are vectors, okay? This vector consists of these 3 things. This vector consists of these 3 things. Now, let me tell you one thing. This one has no relation to this. They do not have any relation. Don't confuse this, okay? These are just class values. I am assuming that cat is of class 0 and dog is of class 1. It has no relation with this one. So if I actually dot product this particular vector with this particular vector, then I get something like this. I think everyone here understands how to dot product between two vectors. 1 into theta
Yes, sir.
3 plus x1 into theta 1 plus x2 into theta 2. So this is what we get actually. And we can actually, in brief, tell that this is our x vector and this is our theta vector, this whole thing. So this is actually x dot theta is equal to this one. Now, actually, what does this mean? What does x dot theta actually mean? If the value of x dot theta is closer to 1, then we shall say that this image x or this sample x represents cat class. No, not cat class, sorry,
Sir,
dog
dog
class.
class.
Dog class, okay, dog class. But if the dot product is closer to 1, closer to 0, if the dot product is closer to 0, then we have to say that this x, this sample x, is actually closer or actually represents the cat class. Are we clear on this?
Yes, sir.
Again, let me recap. If x dot theta is closer to 1, then what we shall say? We shall say that this x image represents an image of a dog. If x dot theta is closer to 0, we shall say that this x image represents the image of a cat. Okay. Now, are we clear so far?
Yes, sir.
Okay. Does anyone have any question up till now? Okay. Still, we have not said how we actually calculate theta. So let me just put this question here. I shall discuss it later on, because how we calculate theta is the basis of this gradient descent optimization algorithm, which we shall cover later on. Now, initially we do not know the value of these thetas. Initially, we do not know the value of these thetas. We have to update and tune these thetas. We have to update and tune these thetas such that x theta, this x theta, becomes close to 0 for images that are of cats, and it becomes close to 1 for images that are of dogs. Let me put this in very, very simple term. Let me just clear this. This was a previous class. Suppose I have 5 images. Okay. Image number 1, x1, x2. This image is of cat. Image number 2, x1, x2. This image is of dog. Image number 3, x1, x2. This is again of cat. Then let me just copy this. Okay, no worry. And finally, another image of a cat. Okay, now we have to update. We have to update the value of these 3 thetas such that this x dot theta become close to 1 for these particular samples, and it becomes close to 0 for these particular samples. Are we clear on this?
Yes, sir.
Okay. Now again the question remains, how do we actually update theta? I have not still told that. And again, I shall answer that you have to use gradient descent optimization, and we shall cover this later on. Okay. Now, the thing is, this is actually a dot product, right? We are actually multiplying some things, multiplying some features with theta1, theta2, and then adding theta3. It is very close. It is very difficult to bring this value close to 0 or 1. This value may jump. This value may become 1,500, right? Or maybe, or maybe 2,500. This value may be anything, because this is just a dot product, which is combination of multiplication and addition. So this is actually difficult to achieve. We can barely bring this value close to 1 or close to 0. For bringing this dot product close to 1 or close to 0, we have to do something which is known as activation function. Activation function. Now there are many types of activation functions. We shall see those in next classes, but today we shall see one of them, which is sigmoid activation function. So let me first define this sigmoid activation function, and then we can move on to how we can bring this value close to 0 or 1. Okay, sigmoid activation function. Let me just search a good image in the internet. So can everyone see this image?
Yes, sir.
Okay. So the characteristic of sigmoid activation function is that whatever value we put in this function, it always returns a value between 0 and 1. If you don't believe me, just look at this picture. The below value is 0 and the value that is above is 1. And all values, no matter how big they are, they will be compressed between 0 and 1. Is it clear from the picture?
Yes, sir.
And if we put 0 inside sigmoid function, then it will actually return 0.5. So what we do is, we actually put this particular theta1, x1, theta2, x2, theta3 through this sigmoid activation function. So let me elaborate. We are assuming the z equal to x theta is equal to this whole vector, and we are putting z inside G is sigmoid. G is nothing but sigmoid function, and G is defined as 1 by 1 plus e to the power minus z. So this value will be in the range of 0 to 1. Okay. Now, no matter what appears as a product of x theta, the value will always be compressed between 0 and 1. Is it clear?
Yes, sir.
So suppose I get value 0.7. So which class does this image represent?
Sir, 1.
One, because dog. It is because 0.7 is always closer to 1 than it is to 0. Similarly, if we get 0.3 here, 0.3 is closer to 0. So it will be classified as class 0. Okay.
Yes, sir.
So this is, I think, fairly simple. It has there is nothing to worry about this. Okay, someone has come, I think. Give the entry. In the meantime, I shall again send the class invitation to everyone, so that each student does not have to send me request for entry. But I shall do it after 1 week, because still I think some more students will register for the course. Okay. Now I was talking about theta 3, theta 1, and theta 2. Here you will have to understand two concepts. One is the concept of bias, and the other is the concept of weights. So what is bias? If you see here, if you look at here, theta 3 is actually being multiplied with 1. 1 into theta 3 equal to theta 3. Whereas theta 1 and So theta3 is actually not being multiplied with any feature. It is being multiplied with a constant value. That is why theta3 is a bias. And theta1 and theta2 is being multiplied with what? Theta1 and theta2 is being multiplied with x1 and x2. So theta1 and theta2 actually work like weights. Theta1 is weighing x1 and theta2 is weighing up x2. That is why theta1 and theta2 are called weights. So is this concept clear? The concept of bias and weights?
Yes, sir.
Now suppose in this particular sample,
bias
I don't have.
আরেকবার বলবেন?
Yes, yes, sure. Bias is that term, that theta or that parameter, which we actually multiply with a constant value. Here that is 1. And weights are those parameters or those values that we multiply with features. Here x1 is multiplied with theta1 and x2 is multiplied with theta2. So theta1 and theta2 are weights. So is it clear now?
Yes, sir.
Hello? Okay. Now, the next thing. Here I shall ask you a question to test whether you have understood everything. Suppose in these examples, in these 5 samples, I don't have 2 features. I have 10 features. Okay. Then tell me, how many weights would there be?
Sir, 10 weights and 1 bias.
9 weights. Oh, sorry.
No, 10 weights. Because if you look at here, we had only 2 features here, and so we needed 2 weights, theta2 and theta3. Sorry, theta1 and theta2. So similarly, if we have 10 features, we would need how many weights? 10 weights,
10.
obviously. And how many bias terms would we have?
So 1.
1 bias term, exactly. Because no matter how many features we have, there will only be 1 bias term. So 1 bias. I think everyone will remember this concept. It's a very easy thing to remember, I think. And is sigmoid function clear to you? Sigmoid activation function. Activation functions are actually somewhat brought rescuers. I would tell you, these are actually rescuers. So what is a rescuer? When you fall in danger, someone rescues you. So if you look at Z, then Z is equal to theta1 x1, theta2 x2, theta3, and these it has very low chance of being close to 0 or 1. So somehow we shall need to bring this particular summation close to 0 or 1. So as a rescuer, we are actually bringing this sigmoid function. So the sigmoid function is actually one kind of rescuer, and these rescuers are known as activation functions. We shall actually see many more activation functions such as redo, then CANH, softmax, and so on and so forth. Leaky ReLU is also there. We shall see them. If you look at our syllabus, then you will see that one class is dedicated to forward propagation and activation functions. So in that class, we shall inshallah see this as well. So is this first phase clear or is there any confusion?
স্যার একটা কোশ্চেন ছিল
Sure.
স্যার মাল্টিপল ক্লাস যখন স্যার আমরা বের করব তখন কি স্যার আমরা সিগময়েড ফাংশন ইউজ করতে পারবো
Yes.
নাকি স্যার আমাদের অ্যাক্টিভেশন ফাংশন চেঞ্জ করতে হবে?
Yes, this is a very good question, and I shall actually answer this question inshallah in the next class, because in the next class we shall go through the introduction of neural networks, and so we shall actually see how multiple nodes are handled. So there we shall actually talk about the concept of multiple. So today we shall just stick to binary class, and tomorrow inshallah we shall actually move to multiple class as well. And let me tell you one thing, in multiple class we actually need softmax activation function, right? We cannot use sigmoid right there. And why we need softmax activation function and what does actually this function define? We shall describe these things in detail. Okay? Are you satisfied with the answer now? For now?
Yes, sir.
Okay. So next, what we shall do is we shall define some terms. So h is actually our predicted value. Why it is our predicted value? Because this value is being predicted by our model, by our logistic regression model. So what is model? Let me ask you, what is actually a model? What does model mean? If I ask you what is model, then what will be your answer? Can anyone answer this question?
Sir, would you please repeat the question?
Yes. If I ask you, what do you mean by a machine learning model? Then what will be your answer?
A system that can predict values from selected data
No,
sets.
that's a very complicated definition. I just ask you what is the machine learning model from the perspective of what is in this page. I mean, from the knowledge of this page, what do you think is the machine learning model? In simple terms, let me answer. This
So
is
there
the
will be
machine
data
learning
set.
model. This is the machine learning model, nothing else. This is the machine learning model. Okay. The values of your thetas are your machine learning model, nothing else. Is it clear? In simple terms, the values of your thetas are your machine learning models. And if I just put it in broader terms, then you have to also take into consideration your activation functions as well, the sigmoid function as well. So if I ask you what is your logistic regression model, then you will have to tell me that these thetas and along with this sigmoid function is actually my logistic regression model. Okay. So when you save a machine learning model, you actually save this information, the values of thetas and your activation function. Is it clear?
Yes, sir.
Because if you actually know the values of your thetas and your activation function, then for any image, you can tell if that image is an image of a cat or an image of a dog. Because when you are given an image, then that image will consist of actually these three things: one, x1 and x2. Just dot product this with theta 3, theta 1 and theta 2, you will get a value, pass this value through the sigmoid function, and you will get a class value, right?
Yes, sir.
So whenever someone will ask you what is a machine learning model or what do you mean by a machine learning model, always say that our machine learning model actually consists of mainly two things. One is the set of parameter values, that is theta 3, theta 1, theta 2, and the other is our activation function, which may be sigmoid function, or depending on your application, it may be ReLU 10H or softness function as well. So this H is actually a predicted value, the value predicted by our machine learning model, that is our logistic regression model. So this value will be something between 0 and 1. And Y is another term. This is our true value. So what do you actually understand by true value? Can anyone tell me?
Sir, what is supposed to be? Like, it's actually dog or cat.
Yes, exactly. When I'm giving my machine learning model an image, suppose image number 1, then from our data set, we already know that image number 1 is the image of a cat. Similarly, when I give my machine learning model image number 3 from our data set, then we already know that this image is the image of a cat as well. So Y is actually our true value, right? So our predicted value will obviously not always be correct. It can be wrong as well, especially initially when we have no idea about these thetas, our prediction will go horribly wrong. And in fact, most of our predictions can be wrong initially, especially when we do not have any idea about what these thetas are supposed to be or what are the values supposed to be of these thetas. That means our predicted value and true value will have some deviations. Do we know what deviation is? Deviation is actually error, right? If y
Yes,
and
sir.
h are not equal, if y and h are not equal, then there will be some error because y is the true value, and our aim is to bring h as close as possible to y for all our samples of the data set. Now again, that same question appears, and it is getting a little bit frustrating for us that we do not know how to determine the values for theta. If we actually knew the correct values for theta, then for all these dot products and this sigmoid activation function, we would get correct values for getting the true levels. For cat images, we would get values less than 0.5, and for dog images, we would get values for greater than 0.5. So now let us define a loss function. Let us define loss function so that we can actually implement this gradient descent optimization to get these values of theta. You have to remember, for any sort of back propagation or gradient descent algorithms, you will always need a loss function. I have mistakenly underlined this log. Log is not an issue. We shall need a loss function, whether it is log loss or mean squared loss or anything. That is a thing of later concern. But what we need is, we will need a loss function. Is this clear so far?
Yes, sir.
Now you will see that machine learning is actually full of mathematics. Okay, this course we have many mathematical things, especially when I will actually go to backpropagation or convolution or anything. There will be a lot of math. So this can be a bit frustrating for students who are actually weak in math, but you will have to try hard to understand these things, because without understanding probability, statistics, or some math, it will not be actually in machine learning engineering. Okay, it will be a diploma in machine learning if we don't understand the maths. So we are actually trying to master the machine learning engineering perspective. So we obviously have to go through the mathematics. But if anyone wants to do diploma in machine learning, then he obviously doesn't need to go through the mathematics. He can actually go through some frameworks, and if he actually understands how to develop simple machine learning models, then that will be enough for him. Okay. So this particular wording of mine can be demotivating for someone or can be motivating for someone as well, some students as well. So I hope that everyone should be enthusiastic to go through the core math of machine learning models. Okay, so let us just go through this loss function first. There are many sorts of loss functions which we shall see later in later classes, but today we shall see one loss function, the name of which is log loss. Okay, so why the name is log loss? We can actually see very clearly that there are many logs here. That is why the name is log loss, and there is nothing to be surprised about this. And this particular function has one other name, and it is very commonly used in deep learning field. The name is binary cross entropy. Has anyone heard this name before? Binary cross entropy. Okay, not to worries. The name of this loss function is binary cross entropy. Okay. Now let me actually go in depth of this loss function. Is everyone with me, or someone has gone lost in the midst of so many theories? Hello.
Yes, sir. We can hear you.
Okay. Okay. So first, let us see if this loss function is correct or not. So how can we test whether a loss function is correct or not? Let me first tell you that. When your prediction is correct, your loss function, your loss value should be what? Should be minimum. When your prediction is wrong, your loss function should be maximum, right? Does everyone agree with me on this? When you make the correct prediction, your loss function should give a very big value, right?
Yes, sir.
Okay, so let us see if this function meets these criteria. Suppose we have y equal to 0 and our prediction h becomes exactly 0. This is a very, very unrealistic case. The value of h will never actually be exactly 0. Because h is what? H is actually a dot product, then a sigmoid function. So h may be 0.3 or 0.05. This can be the value of h. But getting an exact 0 is very, very rare. Okay, do you understand this?
Yes, sir.
But suppose we get a value of 0. Suppose in a very, very ideal case, we are getting a value of 0. That means value is exactly equal to our true value. That means the prediction is correct. Okay, so let us see what the value of this loss function becomes. Minus y is 0 and h is 0, both are 0. So I am putting these zeros here, and 1 minus 0 equal to 1, log 1 minus 0 equal to 1, log 1. For understanding machine learning, understanding the concept of logarithm is very, very important. And I don't know if everyone is clear with this concept. So first of all, I shall go through the concept of logarithm. Then I shall come back into this loss function. First, everyone should actually answer some questions. Let me just take a small test of yours. Okay, tell me. Log 2 base what log 2 base 8 equal to what? What is the answer of this?
So 3.
3.
3. Can anyone understand this, or do I have to explain? Can everyone understand how this 3 comes here? If anyone doesn't understand, please tell me. I shall elaborate this concept. Okay, I think everyone almost understands, so I shall just quickly go through this. It actually means 2 to the power 3, right?
Yes,
That
sir.
is why this 3 actually comes here. Okay. Again, let me take one more test. Log 10 base 100. So what will be the value of log 10 base 100?
So 2.
2, right. Why? Because this 100 is
10 to the power
actually
2.
10 squared. Yes. Okay. So now let me ask you one last question. Log 2 base 1. What is the value of this?
So 0. 2 to the power 0 equals to 1.
0. Exactly. Log 2 base 1 equal to 0 because log 2 to the power 0 equal to 1. So it is 0. That is why we can see that log 1 equal to what? Log 1 equal to 0. Can we understand this part?
Yes, sir.
Okay. Now let me ask you one more question. What is the value of log 0?
So 1.
Log 0 is equal to 1, but why? If okay, let me suppose that this is 1. Suppose that this is 1. That means 0 is equal to what? 2 to the power 1. Is it true? Is 0 equal to 2 to the power 1?
Yes, sir. It's supposed to be 2.
0 is never
No,
2 to the
sir.
power 1, okay? Okay. So 0 equal to what actually? 0 equal to actually 2 to the power minus infinity. Does everyone agree with me on this?
Yes, sir.
2 to the power minus infinity is equal to what? 1 by 2 to the power infinity. That means 1 by infinity. That means what? 0. Is it clear?
Yes, sir. Clear.
That means here I can write 2 to the power minus infinity. That means here there will be what? Minus infinity. Is it clear?
Yes, sir.
Okay. So that means log 0 is equal to always minus infinity. Everyone should remember this because we are actually going to need this property right now. So in this particular state, both terms are actually being multiplied by 0. So the answer will be 0. That is, I think, fairly simple. And in the second example as well, both terms are being multiplied by 0. That is why we shall get 0. But in the next case, where our prediction is actually completely the opposite, the true value is y equal to 1 and our predicted value is h equal to 0, which is very, very, very rare. I think this never will happen actually, no matter how random our model is. Because already I showed you earlier that getting a value exactly value of 0 or exactly value of 1 is almost impossible. You will always get some fractional value like 0.001 or 0.995, etc. Okay. But suppose in a very non-ideal case or in a very drastic situation, we get a value of 0, a completely opposite value of the predicted value. What happens? Let us see. Minus 1 log 0 minus 0 log 1. This is what appears. So log 1 equal to 0. That means this term is actually being 0. That is okay. But let us see the first term. What happens here? Minus, here there is a minus in the formula. This minus comes from the formula. Minus log 0 equal to what? Minus infinity. Is it true? Minus infinity log 0 equal to. I just showed you now. So minus infinity equal to what? Plus infinity. Does everyone agree with me on this?
Yes, sir.
That means this is going to be a very, very big value. And obviously this should be a big value because the prediction is horribly wrong. Okay. So is it clear?
Yes, sir.
So does everyone agree that this loss function actually meets the criteria of an ideal loss function? It is completely wrong. Okay, let us just wait for the Azan to finish and then we shall start again. Okay. Okay, let's start again. Can everyone see my screen?
Yes, sir.
Okay. So ultimately the conclusion is the closer the value of h will be to y, the less will be the loss. Okay. Now there is a very interesting phenomena with the log loss function. I shall first describe this one, then I shall move on to later pages. Let me just clear this page. Okay, now let me define the log loss function in detail. Suppose my true value of y is 1, okay? My value of h is, suppose, 0.99. So let me also put the loss value. So my loss value would be loss. Let me just draw a loss curve type thing. So my loss value would be somewhere right here, right? It would be very low if loss is right here. Then suppose I reduce this h to 0.89. My loss value will also go up. It will maybe go up right here. Pay very high attention here. This is very important. Now then I am going to 0.79. The increase of loss function will be somewhat right here. Then I am moving on to 0.69. The increase will be somewhat right here. Can anyone understand what's happening here?
Yes, sir.
The loss is actually going up exponentially. Is that clear?
Yes, sir.
Yes.
It is not actually going up uniformly. If it went up uniformly, then this point would be right here and this point would be right here. But it's actually going up exponentially. And this is actually required for classification tasks because 0.69 is still in the range of getting us to 1, because if the value is over 0.5, we can still classify the sample as class 1. But suppose if this value of h goes to 0.49, then what happens? Then we are in big trouble, right?
To 0. Yes.
Prediction actually goes to 0. So this is actually very important to understand that going from 0.99 to 0.89 is nothing to worry about, because still we have a long way to go before we fall to the 0 category. That is why the loss is actually not very big. It is fairly small. Okay, but as we move on near to 0.5 compared to this one, our loss becomes hugely greater. Okay, is this concept clear?
Yes, sir.
That is why in classification tasks we actually use log loss. It is very interesting. It is a very interesting concept. And when we shall actually see multi-class classification, which one of my students actually mentioned a little bit earlier on, we shall also see categorical cross-entropy loss, which is actually absolutely similar to this loss function. That is just for multi-class classification, nothing else. And the same concept applies. So in any sort of classification tasks, you must, again I am repeating, you must use log loss. Never use losses such as true value minus approximate value whole square. This is also a loss function, right? This is also a loss function, because if y and h are equal, then this value is actually 0, right? But this function is not good because it sort of increases the loss uniformly, and we do not want this loss to increase uniformly. We want to increase this loss. We want this loss to increase exponentially as our predicted value moves further and further away from y, from the true value. Is it clear? Is this concept clear to you?
Yes, sir.
Yes, sir.
Okay. We should also see regression. No problem. So now we are seeing actually classification. But when we are going to perform regression, we obviously have to use some other kind of loss function. This binary cross entropy will not work with regression. Okay, so for regression, remember that this binary cross entropy loss will not work. We shall have to use some other loss functions. which we shall go through later on. Okay. So again, the question remains, how do we update theta? And we are moving in close to this question because we have already defined our loss function. So first of all, let me just show you a graph of theta versus loss. So from this graph, answer one question. How many thetas are there in this graph? Again, let me repeat. How many thetas are there in this graph? Can anyone answer this question?
1.
Yes, there is only one theta in this graph. Exactly, that's the correct answer because we have mapped theta in only one dimension, that is the dimension x. Now tell me how many thetas are there actually in our model, the model we are discussing now. There can be more than 3 thetas obviously in any non-zero regression model. But in this particular discussion, how many thetas do we have?
So 3.
3.
3 thetas. Okay, right. Now, if we actually want to draw a graph having 3 thetas, then how many dimensions do we need? How many dimensions do we need here? There are only 2 dimensions here, I
3.
know. 4 dimensions because
4.
one dimension is for the loss itself, right? We would need 3 dimensions for the 3 thetas, and 1 extra dimension for the loss. Can we make 4-dimensional plots?
No, sir.
We cannot make 4-dimensional plots. So for simplicity purpose, I am actually assuming that there is only 1 theta. There is obviously 3 thetas, and we shall obviously cover how to handle 3 thetas in this lecture. But for understanding to make you understand the concept of gradient descent optimization, I will need to actually explain this graphically. And to explain the system graphically, actually take more than 2 dimensions. Even 3-dimensional plots are actually hard to understand. So I have assumed that there is only 1 theta. So is everyone clear on why I am taking only 1 theta here?
Yes, sir.
Okay. So we cannot actually forget what we are trying to do. We were actually trying to find an appropriate value of theta, right? So that our model can classify the samples accurately. So initially, do we know the appropriate value of theta? Initially, do we know the appropriate value of theta? Can anyone answer this question? Hello? Hello?
Sir, 0.
No, not 0. Theta can be anything initially. Initially, theta can be anything. You can also initialize this with 0. That is your personal choice. But initially, theta can be anything. You can choose any value for theta. Okay. So initially, theta can be anything. That means initially, theta does not have its appropriate value for classification. So let me just consider that this is the initial value of theta. Is there any problem with that? If I assume that the initial value of theta is here, because theta is
No,
a
sir,
random
no
choice
problem.
initially, no problem. Okay. So for this theta, what is the value of loss? This one, this is the loss value, right?
Yes, sir.
Now, what is the minimum loss value of this particular loss function? What is the minimum value? Here, right?
We can
This
see
is
the
the
So
minimum
problem.
theta
value.
bar.
Theta bar, yes. That means if we can somehow make theta init, this is initial theta. If we can somehow make theta init, theta bar, somehow, then we are happy because we have reached a minimal point. Do we agree with this?
Yes, sir.
Okay. So now how can we actually get the theta init towards theta bar? So let me answer this question right now. First of all, we shall actually need some concept of derivative. So let me put this into perspective first, like I did for log loss. Then we can actually discuss. During AI lab, I did not elaborate these things so much because my main motive was to show the pseudocode. But here I shall elaborate everything, inshallah. So first of all, let me just draw a function. Suppose this is any function. This can be any function, fx. Suppose this is the graph of this function. Let me just draw it a little bit differently for my own ease. Okay. Suppose this is function fx and this is x. Now, if I ask you, determine the derivative of fx on the point x naught. That means determine f prime x naught from the graph. Then what would you do? From the graph, again, let me rephrase the question. Tangent. Okay. I think many students do not understand this concept, so I am again repeating this concept. First of all, understand the question. Then I shall give the answer. You have a function fx. Suppose this is the graph of function fx, and I am taking any point x naught on the x-axis, and I am telling you determine the value of f prime x naught. That means, if I say it in plain English, determine the derivative of fx on the point x naught. Okay, at the point x naught. Determine the derivative of fx at the point x naught graphically using this graph. Is the question clear?
Yes, sir.
Okay. In order to do this, what we shall do is we shall first draw a tangent. Right here. So let me draw a tangent. Tangent means sporshok in Bangla. Sporshok, I think we all know, because even if we are Bangla medium students, we know obviously. So if we draw a tangent or a sporshok in this point, it will actually intersect the x-axis at this particular point. Okay. Now, what is the angle? What is the angle that this particular line produced with the positive direction of the x-axis? First, let me just put one thing. Which is the positive direction of the x-axis? Tell me. Is this the positive direction or is this the positive direction? Which is the positive direction?
Sir, first one.
First one. Why? Because this is the anti-clockwise, isn't it? Anti-clockwise.
Yes, sir.
Normally, the clock actually goes like this, right? The clock from 12, 1, 2, 3, 4. This is the clockwise direction. And this is the anti-clockwise direction, right? This is the anti-clockwise direction. Is that clear?
Yes, sir.
Always remember that the direction, anti-clockwise direction compared starting from x is the positive direction. So if I actually draw the angle in the positive direction from x, then the angle is like this. This is the angle that this particular tangent produced with x-axis. Suppose this angle is, I think I shall not use theta here because theta is actually a parameter. So I shall use A. This is the angle. Okay. So is this clear? How we are getting this angle A? Does everyone understand this?
Yes, sir.
Okay. So the final answer, f prime x naught is equal to tan of A. Okay. Is it clear now? How do we get the derivative from the graph?
Yes, sir. Clear.
Okay. Always remember this. This is a very basic concept, and we will need this in many places. So try to remember this concept. Very interesting. Now, answer me one question. Is tan a positive or negative in this particular picture? Is tan a positive or negative?
Sir, negative.
No, obviously positive.
Sorry,
Tan of
yes,
45 degree
Tan of-
or
yes,
tan of 60 degree.
positive.
Anything less than 90 degree. Anything less than 90 degree is what? Positive.
Positive, sir. Yes, sir.
For tan, any angle less than 90 degree is positive. So tan A is positive. Okay. Okay. Now, is this clear up to so far? Do we understood? Have we understood up until now about the positivity?
Yes,
Tan A
sir.
is positive. Okay. So again, let me come here. So tan A is positive. We can understand that. That means the derivative is positive. But in order to go from here to here, in which direction should we move? Positive direction or negative direction?
Sir, here negative direction.
Negative direction, right? That means remember one thing. When our derivative is positive, the theta movement is in the what? Negative direction. Is that clear?
Clear, sir.
Yes, sir.
Okay. Again, let me redraw this picture. Let me just use. No problem. I don't need this. I actually can do this. Now, suppose we are not desiring f and x naught. We are moving to some other point x1. We want to get a derivative in f prime x1. So in x1, this is the x1 point, I think. Okay. So again, what we do, we are drawing a tangent right here. So let me draw a tangent. No. It isn't a good tangent. Okay. So now tell me, what is the angle in the positive direction of x from here to here, right?
Yes,
Let
sir.
me rename this. This is a prime. So is this angle less than 90 degree or greater than 90 degree?
Greater than.
Greater than
Greater than
90.
90 degree, right? So as it is greater than 90 degree, what will be the value of tan a prime? Positive or negative?
Sir,
Negative.
negative.
Negative, right? Is everyone, does everyone agree with me on this particular point?
Yes, sir.
Okay. So tan a prime is negative. That is, I think, clear to everyone. Now, let me move on to the next thing. If we are starting from right here, suppose this is our theta. In which direction do we desire to move? Positive
Sir,
or negative?
positive.
Positive. That means when we are getting a negative value of derivative, we are actually moving to the positive direction. In summary, in which direction do we actually move? The direction opposite to the derivative. Is that clear?
Yes, sir, clear.
We always move to the direction opposite to the derivative. Okay. So theta equal to actually theta minus dv. dv means what? dv means actually this, the derivative.
Yes, sir.
Here, loss is a function of theta. Loss is a function of what? Theta. That is why we are actually taking derivative with respect to theta. Okay. Now, some students will disagree with me. Sir, J is not a function of theta. Rather, it is a function of y and h, right? Do you see any theta here? Can you see any theta?
No, sir.
No, sir.
But I am telling that this is a function of theta. But how? Okay, let me elaborate. First of all, answer some questions. We have two y's here. Are these variables or constants? These y's, are these variable or constant?
Sir, constant.
Variable, constant. Why is this constant?
Sir, 0 or 1? True level.
I can define a variable like this. Suppose the variable x, it can have a value of 0 or 1. So it is a variable, right? X is a variable. It can have, constant means what? Constant means only one value can be assigned to it, right? So for that discussion, is y a constant or a variable?
Sir, variable.
Variable.
Yes, this is a very confusing question. So now the answer was correct. What is your name? The one who answered that it's a constant?
Sakib Ahmad.
Okay. Samad, your answer is absolutely correct, but why y is a constant, that answer was not correct. So now I am actually answering that question. Okay. So first of all, answer, where does y come from? Where does y come
True
from?
value.
The data set, right? Y comes from the data set. Does everyone agree with me?
Yes, sir.
Because in data set there are two parts, x and y. And for each sample, there is a y fixed. Now, answer me this question. Can we change this y according to our own will? Can we change? I mean, suppose I am wishing that, okay, I am not liking this particular value, so let me change this to 0. Can I do this?
No, sir.
I cannot do this because the data set is fixed. The person who made the data set has made it so that people use that data set. That the data set, the person who actually produced the data set did not actually produce it so that people can manipulate it, right? He produced it so that people can use this data set in order to train their model or validate their model. So these values are not changeable. You cannot change these values. So whether the value of y is 0 or 1, you have to keep it that way. You cannot change it according to your own will. That is why y is a constant. Is my answer satisfactory to you?
Yes, sir.
Now, if I go to h is a variable. Why? Because h is actually predicted by our model. H is actually predicted by what? By our model. And in our model, h is depending on sigmoid function and theta 1, theta 2, theta 3. We have already told that we are going to update theta. Does anyone remember this point? We are going to update theta.
Yes, sir.
So what? So in a programming problem, what do we update? We update variables. That means h is a variable because h is depending on what? It is depending on thetas, right? It is
Right,
depending
sir.
on what? It is depending on thetas. Now, one may also argue with me, sir, there are x1 and x2 here as well. What about them? But x1 and x2 are what? Are constants. Because where do we get x1 and x2 from? Where is x1 and x2? In the
From
RMS
data set.
dataset, that is why x1 constants. So now everyone understand why this particular function, this particular j is a function of theta, because j is actually depending on h, and h is actually depending on what? Thetas. Please ask questions if there is any confusion regarding this issue. Hello? Hello?
Yes, sir.
Is it clear?
Yes,
Or is
sir.
there any confusion? This particular question was asked to me by my PhD interviewer at NUS. So these concepts are actually very important. Now I think you can all understand this. Because no professor will ask you about frameworks. They will ask you if you understand the core concepts. So it is very important to understand these things. Again, let me repeat, y and y are constants. H is a variable, so j is a function of h. But h is actually depending on theta because x is what? X is a constant because it comes from data set. So h is a function of theta. That means indirectly h is depending on theta and j is depending on theta as well. That is why j theta. So okay, up until here, does everyone have any question? Please go on if everyone has any question up until so far. And I would request the new students to join the Facebook group The group link has been given by the seer in the comment section. So please join the group. This group is for actually collaborating. You guys can communicate with each other. There are students from very different batches. So it will be easier for you in this way. Now, let me again come to the point. So shall I proceed?
Yes, sir.
Okay. Now, if I actually take the derivative of j using theta, then this particular term actually appears. You can do this manually if you want, but I have just written the answer directly because the derivative is not very easy. It is almost 2 pages long, but this particular answer will appear. But you can try this at home. So if you actually look at this derivative, there are three things. X, this is a vector. This is a vector. X equal to actually 1, x1, x2 in our problem. Then there is h, and then there is y. H is a value, the predicted value, and y is the true value. So we actually know all these terms, right? Does anyone have any confusion with these terms? Hello? Okay, if no one has any confusion, let me proceed. And there is a negative, theta minus dv. Why is there minus? Can anyone tell? Hello? If you have understood this graph, then we should be able to answer this question. Anyone? This minus value is because we are moving into the opposite direction, right? When derivative is positive, theta movement is in the negative direction. When derivative is negative, movement is in the positive direction. Now is it clear? Hello?
Yes, sir.
Well, I would really appreciate if the class would be a little bit interactive, because I would not understand if students are understanding or not if you don't respond. Basic topic, and the topics that are coming later will be based on this. So it is very important that you understand these concepts. Okay. So theta minus dv, we have already shown how to calculate dv. This is the dv calculation. So theta equal to theta minus dv. This is how we update. Now the problem is, do we update theta only once? I mean, can we just jump from here to here? I mean, is it that easy? What do you
No,
think?
sir.
It is not that easy, right? We want to iterate. We want to move in small steps right here. Now we actually don't know how big the value of theta is. The value of theta may be very, very big, or the value of theta may be very, very small. There can be many issues. A big problem will arise if the value of dv, this dv is very big. The value of dv is very big. What problem appears right here? When the value of dv is very big, then what appears is that when the value of dv is very big, then what happens is that in one jump we can move from here to here, right? Because theta minus dv, and the value of dv is very big, so our jump will be very big as well, right? Does everyone agree with this?
Yes, sir.
If the value of dv is very big, if suppose we are here, same scenario will occur. We shall jump in the opposite direction, that means right here. But we actually don't want to do this. We actually want to take very small steps towards this optimal theta bar, right? That means we need some mechanism to actually reduce this subtraction. We would not want to subtract theta minus dv directly. We want to actually multiply dv with some small value so that we can take small steps like this, right? That is why we actually multiply dv by a learning rate, So I think today I shall stop here. From learning rate, I shall actually proceed in the next class because time is almost over today. I would request everyone to actually go through today's class recording before coming into the next class, because or else it will be difficult to understand the next topic or the things that we will teach in the next class. The thing is, machine learning course is somewhat like SPL course, because in SPL course you have already seen that without knowing for loop you cannot understand nested for loop, and without knowing nested for loop you cannot understand matrix. We all know that, I think. And students in the first year make one big mistake, that they do not become serious in the initial classes, and then they try to cope up with the classes in the later onlines, and then they see that they are understanding nothing in spite of trying very hard. They become frustrated and then they drop the course. So the same thing may happen in this course if we actually do not follow the class lectures on a regular basis. Okay. So I think it is very, very imperative, and I suggest you this very firmly, that you should go through at least once the class lecture video and the slide. I shall upload the slide, no problem. Okay. So just go through it before the next class begins. Okay. A big silence. Big silences mean actually two things, one of two things. Everyone understands everything, or nobody understood nothing. Okay, these are the two things. So whenever I actually teach mathematics in UIU, mathematical related topics, I hear big silences in classes. So I don't know. It can be either of the two. So okay, I think the class time is almost over, and I think the decision is not yet over. So it is not very wise to take attendances in these times. I will also give attendance to everyone in the previous class, because many students could not register by then. So inshallah, from the next class we shall take attendance seriously. Okay.
Okay, sir.
Okay, sir.
Okay then. Allah Hafiz.